So welcome back. We will start with another set of sessions. I'm glad that I can welcome Mike Kay again here. And probably you know that XMLPrague and University is trying to at least a little bit support development of XML-related standards. So we have been hosting XSLT and XQuery meetings, I don't know how many times, 6, 7, I can't recall. So in past years, there has been a lot of work done to create new version of those standards, and I think that a lot of people are looking for final versions and are asking questions. Could we start using this in production or not, or when? So I think that during this talk, Mike will give you some answers.
Okay. We've been coming here sort of every year for the last N years telling you that these standards were almost ready. So I'm going to give you some really exciting news this year, which is that they are really almost ready. XPath and XQuery 3.1 went to a proposed recommendation. If you're not in the standards world, being a proposed recommendation doesn't sound very exciting, does it? But given that a recommendation means it's the real thing, it's a standard, it's the final, that's an act of parliament in the standards world as a recommendation. It means you've finished. Being a proposed recommendation means that you're in the final voting. So it's like a bill before Parliament that you're asking people to vote on. And if they say yes, then it becomes an act of Parliament. So it means all the technical work's done. There's just a bit of politics that people have to vote yes. And in the vast majority of cases, you can jolly well expect that unless there's some really nasty politics behind it, they are going to vote yes. And so we're done. So proposed recommendation really should mean we're finished. XSLT 3.0 is just a little bit behind that with a second candidate recommendation. Just to give you the story there, XQuery was a few weeks ahead, and they went to the review process in W3C that says we want to go to proposed recommendation, and the review meeting concluded that the level of change since the previous candidate recommendation was actually too high for that, because a couple of hundred bugs fixed and a few technical changes made and 1 or 2 functions added and things like that. And that's actually higher than the level of change that W3C allows for transition from candidate recommendation to proposed rec. And so they said, no, we need another candidate rec so people can review those changes. And so they went in for another candidate recommendation stage before Christmas for the minimum period of 4 weeks or whatever it was that you're allowed to have, and then progressed to proposed recommendation after that. XSLT 3 is in the same position, that the level of change was too high to go straight to proposed recommendation. Therefore, they went to a second candidate recommendation first. And the expectation is that will transition after a month in the middle of March to being proposed recommendation, unless there are technical objections to the changes that we've made in the meantime. So I think that's where we are at the moment. We're done. We should be cheering. Let's cheer. Incidentally, some of you were here last year when Abel Bruxmer and I were holding a workshop on XSLT 3. Some of the feedback from that workshop indeed found its way into the spec. It took us several months to sort out some of the ideas that came in terms of turning them into changes into the specification, but they did have an impact. That's one of the reasons it took us another year. But that was very useful feedback, in fact, in terms of some of the, it was all about the fallback from streaming capabilities and the orthogonality between streaming and non-streaming in the spec, so that streaming processors and non-streaming processors give the same result when executing a style sheet. In going to recommendation, one of the things you have to do in the W3C process is to demonstrate interoperable implementations, and that's done by demonstrating test results. We're actually going to be working next week on the test reporting for the XSLT spec. But as I say, XQuery and XPath are a little bit ahead. And just to give you an example of the kind of process that we go through, vendors are right through the whole process, a test suite's developed, and the number of tests for XQuery there, you can see, is about 30,000, of which about 21,000 are XPath tests. And implementers of products are asked to submit results according to those test suites, and those vendors who submit results, the results are collated and they're used as part of the report to WCC management to show that you actually have interoperable implementations. And the leading reports that we got were from Saxon, BaseX, and XMLPrague. And these are the sort of results that were being reported. So both Saxon and XMLPrague reporting, sort of 10 to 30 failures out of 30,000 tests. And that's considered an adequate level in terms of proving interoperability, partly because it's justified by a detailed analysis of what the tests were that were failing and why. For example, there are 4 tests which were failing because failing in the sense that not enough implementations passed them, and it turned out those tests require an XSD 1.1 processor, and 2 of these people reporting implementation results didn't have an XSD 1.1 processor, and therefore weren't able to pass those tests. And that's within the criteria, because you don't have to support XSD 1.1. Other sort of reasons for failing tests. Tests designed for processors that allow collection stability to be disabled. So if you don't allow collection stability to be disabled, you can't pass that test. It's an example of the kind of metadata associated with the test that describes the dependencies on the test, dependencies on features being present, on features being absent. And the idea is that if a test is dependent on Unicode 8.6 and you don't support Unicode 8.6, then you just declare that by not running that test and saying, I'm not running that test because my product doesn't satisfy that optional dependency of the spec. Yeah, so they're tests depending on Unicode version and all sorts of things you find in there. So that was the test reporting, which is part of one of the hoops you have to jump through to prove that you've got an interoperable set of products. So, why is it significant? Does it matter? And of course, we get terribly absorbed in the process. All these new features are terribly wonderful. They're really going to change the world. They're going to prevent climate change. They're going to provide a cure for cancer. It's all going to be wonderful. But then when you think about it, what does it actually mean to have a concatenation operator instead of having to call a concatenation function in terms of the future of the planet? So I've tried to sort of bridge that gap from the wonderful, cool new things that programmers can do to what's actually the strategic significance of having these standards. So I've tried to. I'm certainly not going to give a catalogue of features today. That's not the aim at all. What I'm going to try and do is sort of distill what's significant out of the massive change over a period of. Let's face it, it's 10 years since XSLT2 came out. Yes, on the XQuery side, we've had a 3.0 and a 3.1, so it's a bit more incremental than that. But it has been a long time coming. So I'm going to try and pull out some of the strategic things that mean these languages really can do things that they couldn't do before, that change that move the goalposts in terms of what these technologies are capable of. Category B is things where I think you could produce a business case that says this feature produces measurable productivity benefits. proving productivity benefits always is problematic because doing the measurement is expensive. But I at least contend that if you did the exercise of assessing the productivity benefits, you would discover a positive plus. And then category C are things like the concatenation operator. They're just things that make your and my life easier and less hassle and fewer keystrokes and produce more readable code. And I could never justify that to anyone as being worth investing in. But yet, it's the things that make the language popular. It's the thing that mean people don't go home at the end of the day screaming, "I hate this language." And to me, those are often the most important thing to do, rather than the things you can justify to managers with money. It's the same in a software release as with standards. So what's strategic for XQuery? I think the two really strategic things are higher order functions and JSON. Why are higher order functions important? They aren't important just because as programmers, we love the elegance of writing with higher order functions, and it feels so cool, and once you've used them for a while, you can't imagine programming in any other way. But that's not what makes them important. What makes higher order functions important is that it is the first dynamic capability in XQuery. It's the first, with XQuery 1.0, if you wanted to handle two different inputs, you had to do if X, then do this, else do that. And the difficulty with doing an if, then, else construct, every time you have to handle variety in your input, is that every time you want to increase the variety of inputs that you want to handle, you have to go to every if, then, else expression and add another branch. So that kind of, COBOL conditional capability, we all know is disastrous from the point of view of software evolution and change, because you can't accommodate variety that way in a scalable way. I first saw this with an application where it was simply a case of handling two different flavors of Swift message input, a version 1 and a version 2 as input to the XQueries. How do you write the XQuery so that it can handle inputs from either source? And I found the team I was consulting to had got codes where single time they looked at an input, they couldn't just say, get X. They had to say, if it's this kind of thing, get X, otherwise get some other path. And they'd in fact devised their own scheme of handling the dynamic variability by generating the XQueries from something else. So they'd found a solution to the problem, but it involved another layer of language on top of XQuery. In XSLT, of course, that's not so significant because we've always had template rules. And template rules are another dynamic way of providing conditional capability in a program. They're another way of handling variety in your input without hard coding it into if-then-else statements. But for XQuery, higher order functions are the first way of doing that. It means that you can pass as a parameter to a query the actions to be performed under different conditions, and an XQuery function can be written generically in terms of parameterized actions that are supplied to it parametrically. So it's not just a cool way of programming. It does fundamentally make larger scale, more scalable applications more capable of potential for change, feasible. And the other thing I think of as being strategic is JSON support. I don't myself adhere to the school that says XQuery is going to be used as a language across the web for processing JSON. And I think there are two reasons why I don't believe that. One is cultural. XQuery clearly comes from a different background and doesn't appeal emotionally to people who aren't au fait with that background. So we do have cultural affinities with languages. They appeal to mindsets. And so I don't think we're ever going to get XQuery appealing to that mindset that isn't schooled in the XML way of thinking. But at the same time, I think it is strategic because people using XML are almost invariably not only using XML, they're using other things as well. And I think it's very important that for those tools to continue to meet the requirements of people who see themselves primarily as XML developers, it's very important that the tools are able to meet the full range of their requirements, which certainly include processing a lot of things other than XML. So I think JSON falls into that category as well of enabling the scope of the language to different applications to increase. What's important at the same level for XSLT? Streaming and packaging are both, in a sense, about scalability. And scalability is a slightly mixed sort of thing because I think you get to the position where XSLT1 can handle 60% of the requirement, XSLT2 can handle 80% of the requirement, XSLT3 can handle 90%. There's a sort of asymptotic curve as you add more capability to the language and it gets a little bit closer to being able to do everything. But certainly I think there are quite a significant number of people who've hit the scaling limits in terms of document size, where streaming is intended to address the requirement, and in terms of application size and complexity, where packaging is designed to address the requirement. We always use sort of DocBook and Ditter as the canonical examples of style sheets that have grown to a monstrous size. But they aren't the only ones. I mean, I've seen in-house collections of style sheets that run to 250,000 lines of code. And if you're dealing with things on that sort of scale, then you really need the software engineering infrastructure of controlling modularity, of controlling separate compilation, of distinguishing what's visible and what's local to a package and what's exposed to the world. The whole business of managing interfaces, managing software change is needed when you're writing programs that are 250,000 lines of code in size. And so I think packaging is very strategic there. The question mark, of course, is with packages is that if people want to write utility packages and make them available to the whole XSLT community, then that's only going to work if the whole XSLT community is using XSLT3. And our experience over the last 10 years tells us that that's unlikely to happen because 60% of the community only needs XSLT1. So there's a real problem there in terms of moving the base forward such that people can actually take advantage of the new capabilities. There's one very little feature in XSLT3 which is hardly ever mentioned. In fact, it's more in the serialization spec than in XSLT itself, and that's support for HTML5. But although it might only be a tiny change to the spec, I think it's a very significant change in terms of something that people need, because the web these days is HTML5, and you need to generate HTML5, and you can't do that with XSLT2 out of the box. It might be that some XSLT processors have added that capability, and it's easy enough to add. But you definitely need HTML5 generation these days, and you get that with XSLT3. And then JSON, I've already mentioned, it's in XSLT as much as it's in XQuery. So moving down the scale, if you like, from these strategic things to the things where I think there are real productivity benefits. I see an awful lot of people being able to take advantage of parsing and serializing from within the language. It changes the ballpark from just using XSLT and XQuery as components in your pipeline to being able to control the pipeline from within the languages. There are a lot of reasons why you want to do it. One is people's wretched habit of nesting XML within C data sections. And you need to be able to construct those composite documents that have XML nested within XML as text. You see people needing to do it because they're reading XML from databases or writing XML to databases. Or the fact that you couldn't parse and serialize within the language, I think, was a major limitation that's lifted. Maps and arrays are there partly for JSON support. But once you start using them, you really realize how much you missed them. For the first time now, you've got a decent set of data structures within the language that are composable and orthogonal and can be used to manage the internal data of your application in a way that, quite frankly, XML really isn't well suited to. Why is XML not well suited to the task? All sorts of reasons. For example, the value of an attribute can't be a list of numbers. It can only be a string. So how do you manage something where what you want to manage is a list of numbers? You can have a variable that's bound to a list of numbers, but what happens if you want to index a set of lists of numbers by name? You can't really do that well and conveniently with XML. You can do it with maps. And so you've suddenly got much more powerful data structures within the language, and those make the difference in some cases between the feasibility of writing an application in XSLT or XQuery and having to switch to a different programming language to write that bit of code. UCA collations. Collations, you get a big groan from a lot of people when you talk about collations, but they are important. People do want to compare and sort data in an international way. The 2.0 spec sort of compromised there. They said you can have any collation you like so long as you know its name. But we'll leave someone else to standardize the names. And of course, no one ever did. So what we've now got is a set of standard collation URIs, a way of referring to the collations defined by the Unicode Consortium for doing international collating. And you can use those collations in an interoperable way. And I think that will turn out to be important for a lot of applications that are processing international data. Generalized collections, I might mention. The collection function is another case where it was sort of there in the previous generation of standards that said you can invoke a collection provided you know its URI. But how everyone forms URIs is up to them, so the actual collation URIs might not be interoperable. Well, that's still true today, that the collation URIs might not be interoperable. But the collation, did I say collation or collection? I always get it wrong. But the collections themselves are now a much more powerful concept. You can now have, it's not just collections of XML documents, you can have collections of anything. You can have collections of JSON documents, you can have collections of unparsed text files, you can have hybrid collections consisting of multiple of those things. Collections provide a very, very powerful abstraction for the interface between your XQuery or XSLT application and the data resources in the outside world. And it's become a more powerful abstraction than it used to be. As always, you know, the input-output facilities in a language are always a nightmare area in terms of interoperability, because you want the input-output capabilities to be abstract enough to handle any kind of input and any kind of output. But at the same time, you want them to be concrete enough so that common cases like reading a text file are actually interoperable across different implementations. Collections possibly veer a little bit too much on the side of abstraction. But it is a very powerful abstraction, and if vendors and users between them exploit that abstraction to the full, then the interoperability between XSLT and XQuery and the rest of the programming ecosystem certainly increases. And then there's the little things. Little things are the things that leave you with a smile on your face, saying, I'm so glad I don't have to do that anymore. And new operators, the bang operator, stops you having to force expressions every time you want to iterate over something. The concat operator. People sometimes ask, why did we choose these symbols? Well, very often, 6 different symbols were put forward, and someone found a good objection to 5 of them because they clashed with something, and so the 6th one was chosen. It's very hard to find symbols that aren't already used for something else, that have the right kind of, that look right on the page. Double vertical bar for concat. A lot of people looked very strangely at that and said, where on earth does that come from? Answer is, it comes from SQL. So, there is a language that has used double vertical bar for concat, and millions of people use it, so there is a precedent. And if you think it means an OR operator, then sorry, you've been using the wrong languages. The arrow operator allows you to do function chaining. So instead of calling translate of substring after, of substring before, of string length, you can now chain these functions together. So the first argument of the function call is special. You can say, do translate, put the result into substring after, put the result into substring before, and you end up with vastly more. If you've got 4 nested functional calls, then suddenly it becomes readable where it wasn't readable before. A few others. Text value templates in XSLT, I mean, that is just wonderful, getting 90% of your XSL value of statements. Everyone will appreciate that. You can just use curly braces instead. Union types are a bit of a sort of personal thing I've pushed for very heavily. You can now write functions that operate on a date or a time, rather than having to make it operate on anything or write 2 separate functions or whatever. And I think that's an enormous convenience in the real world, being able to write functions that operate on arguments of several different types. It's a bit inconvenient because you have to go and define a union type. That's easier in XSLT than in XQuery, because you can have a little local schema in the top of an XSLT style sheet that just defines a union type that you're going to use in your functions. And I'd suggest doing that. It's a handy technique. But you can go and find out more about those. Those are my sort of personal selections of the things that make a difference when programming. So where are we? We've finished, except for the final WC sign-off. And I think we've been successful. We're successful measured by the number of interoperable implementations of these standards, by the extent to which they are deployed in critical applications. There are some people who are disappointed that there are still other programming languages around for us to compete with. Personally, I'm not. I'm quite happy to have a critical mass of users. I think they're successful measured by the quality of the language specifications, and by the existence of a thriving user community that uses them. So we're done. I'm going to be very happy to have my Tuesday and Thursday afternoons off, rather than hearing the chimes of the voice conferencing system inviting me to meeting number 689. Having done this for nearly 20 years, I'm quite happy to say, right, it's time I moved on to something else. We've done a good job there. Let's find something else to do. So thanks very much.
So So thank you very much, Mike, not only for this talk, and we still have some time for probably 2 questions over there.
Mike, your category B, things that could make some difference. One of the things I think you possibly could add to that list might be the accumulators in XSLT. I think that's going to be the work I've done and started to use them and suddenly realized that there's actually a slightly different programming paradigm sitting in there for some particular sorts of problems that actually things fall out very, very well indeed. I know I know they were put in for streaming support, but I think they've got something much more interesting in there.
Yep. It's going to be interesting to see what people do with that capability. Okay.
Is there some other question? Just say this.
Michael, first of all, thank you very much, both for the nice overview talk and, of course, for the 20 years of work that I think is very impressive and we're all very appreciative of. This is a question that perhaps should be shot at just as much at Liam as you. It's what happens. You probably quite correctly say, okay, we're kind of done with this now, but N years from now, something's going to come along that somebody is going to something's going to change, interestingly, in how XML works, how the web works, how we think of things, some new definition.
Yeah, I actually sort of cut a bit of speculative slides about the future from the slide set. There are 2 things that could happen. One is that in 5 or 6 years' time, there's pressure to reopen the box and do a bit more work, which could happen. It's happened, it's happened to COBOL and it's happened to Fortran and so on. That a dormant standards committee has been reawakened to produce a new version because of popular user demand. The other thing that can happen, and which I hope will happen, is that we get a new generation of query and transformation languages that do the whole thing again, but much better. I hope this isn't. I hope we haven't invented the last XQuery, the last query and transformation language. And one thing I hope they will do better is do one language that does both, rather than doing 2 different languages that do 3/4 of the job each. But great ideas we heard in X definition this morning. There's more than one way of skinning the cat, and I hope people will come up with some new creative technologies that make what we've done for the last 20 years obsolete.
Okay, thank you very much. We should proceed with the next session because,